Hello, welcome to the Extraordinaire. Today we're going to be looking at tuples and sequences. It's going to be a very brief episode, so let's get into it. We saw that lists and strings have common properties such as indexing and slicing operations. Those two are examples of sequence data types. Since Python is an evolving language, other sequence data types may be added. There's also another standard sequence data type, which is the tuple. A tuple consists of a number of values separated by commas. For example, let's create a file, say example1.py, and we can define a tuple t 1 2 3 4 5 5 4 3 2 1 and hello. Then we can access these values in this tuple by using an index. So we could say print t0, and when we run this example 1, we get the value of the first item in the tuple. We could also print the entire tuple, print t, and what do we get? So we get the entire tuple when we print the tuple itself. Now tuples may be nested, so we can define another tuple u, which is t comma 1 2 3 4 and 5. And when we print u, what do we get? We get the tuple for t, and we get the value of 1 2 3 4 5. Because now we've nested those two together to create a new tuple, which is u. Tuples are immutable. What that means is that we cannot, once we've created a tuple, we cannot modify it. So let's say an example. If we try to do t0 and we say that is equal to 8888 and we print this, we get an error. And why is that? Because tuple object does not support item assignment, because tuples are immutable. Now, even if the tuples themselves are immutable, they can contain mutable objects. For example, we can have a tuple. Let's comment this out. We can have a tuple v, which is equal to 1 2 3 and 3 2 1. And if we print v, we get the values of v. But we can also append something to v, because v is we can also append something to v0, because v0 is a list and a list is mutable. So let's say that v0 dot append, and let's say we want to add 32. Now after appending, let's print it again. What do we get? Can you see 32 has been added to v0? So even if the tuple itself is immutable, it can contain items that may be mutable, like lists. Though tuples seem similar to lists, they are often used in different situations. They are used for different purposes. Like we said before, tuples are immutable, and usually contain a heterogeneous sequence of elements that may be accessed via unpacking or indexing, or even by an attribute in the case of named tuples, while lists are mutable and their elements are usually homogeneous and are accessed by iterating over the list. So a tuple is heterogeneous, meaning it can contain different items in it. So it could have a string, an integer, it could have a boolean value inside of it, like we have in this case where we have numbers and we also have a string as part of the tuple. But for lists, in most cases, the list items are of the same data type. We could access a tuple with an index. We can access it with an attribute name in the case of named tuples, and we could also access it via unpacking. While for lists, we have to iterate over the list to access its items. A special problem is the construction of tuples containing 0 or 1 element. The syntax has some extra quirks to accommodate this. Example, empty tuples are constructed by an empty pair of parentheses. A tuple with one item is constructed by following a value with a comma. It's not sufficient to enclose it a single value in parentheses. Even though the syntax may look ugly, it's very effective. Let's take a look at an example. Create a new file, save it as example2.py. Now we can create an empty tuple like this and print it. Print empty. And what do we have? We say that it's an empty tuple. We could create a single value tuple like this. So say singleton hello. I'll have to remember to put a comma in front of it at the end of it. If not, it would not say Python would not recognize this as a tuple. And if we save and print the singleton, what do we have? We have a singleton tuple. The statement T equal to 1 2 3 4 5 5 4 3 2 1 hello is an example of tuple packing. The values 1 2 3 4 5 5 4 3 2 1 and hello are packed together in a tuple. The reverse operation is also possible, and that is called tuple unpacking. So like we saw in the previous example here, where we have this is called tuple packing. We can do the reverse of this, which is called tuple unpacking, where we take these values and assign them to independent variables. One thing to note when we are doing tuple unpacking is the number of variables need to match the number of values in the tuple. So let's see an example. We'll create a new file. Call this example 3. And then we're just going to copy this value here. Use this to define our tuple. Example 3. And then we're going to assign each of these into a separate value, x, y, z. So we are unpacking this tuple into x, y, and z. Then we would print t equal to t and print x equal to x, print y equal to y. Let's correct this. And finally print z equal to z. Let's run this and see how it looks. Very good. So we have our tuple, then we have the value of x, which matches the first item, y, which matches the second, and z, which matches the third and last item. And that's it for tuples. In our next episode, we're going to look at sets. I said it was going to be a very brief episode. If you enjoy the content, please subscribe, like, and share, and I'll see you in the next one. Bye.